Okay, so our rule in a function definition is in terms of the input. So when you say percentage grade in terms of the letter grade earned, what is the input? Letter grade. Letter grade. Okay, and what's the output? The percentage. So now what question do we ask to see if this is a function? For every letter grade, say a B. What for a letter grade of B, that needs to have a single output. Every time there's a B, a student gets a B, it has to be the same percentage grade. Yes or no? No. Right, because a B could map to an 88, it could map to an 83, an 82, etc. Not a function. So this is no. Questions on that? All right, now if it says the other way around, it says the letter grade earned in terms of the percentage grade earned. What's the input? Percent. Output? Letter. Is it a function? Yep, because if the input's a percent, say 78. Well, on a certain teacher's grading scale, on mine, 78 is a B minus. If you get a 78 in this class, you get a B minus. And it won't be a B, it won't be a C plus, it'll be a B minus every time. Every student who gets a 78 gets a B minus. Okay? That's a function. Every student that gets an 82 gets a B. Every student that gets a 98 gets an A plus. Okay? That's a function. All right, how about this other one? Number 4. So we've got this table. The average rainfall with respect to the number of months. What's the input? Average rainfall with respect to number of months. So T is our input. Number of months equals T. Output then is R. Okay? Is the rainfall. Is this a function? So basically what we're asking is, after a certain number of months have gone by, is there just one value of rainfall for a certain amount of time? Is there just one value of rainfall for any given amount of time? Oh, but what about the fact that both after 1 and 2 months it's 1.1? Is that a problem? No, the problem would be it's impossible for a measurement at 2 months to be more than one measurement. That would be the problem. The measurement for 2 is 1.1. That's a function. The measurement, or because it's always true like that, it's a function. The measurement after 6 months, 0.9 inches of rain. Okay? So this is absolutely a function. What about the other way around?
I just have a question.
Sure.
I didn't really get the relationship of function and that. Like, the only thing I understood that it says the input was the number of months, right?
Yep. The first row. So the first row is the input quantity. How many months since January 1st?
Yeah, but when you have 1, you get 1.1, and you get 2, you have also 1.
Right. But what's the definition of a function? For every input,
you get 1 output.
you get only one output.
Yeah, but you have the same outputs over here.
But what's the definition of a function?
Each input has.
Does that input have one or more than one output?
Just 1.
Has just one. Does that input have one or more than one output?
Yeah, 1.
Just one.
But they're the same value.
So if I have a desk phone in my office, and I have a cell phone number, 2 different numbers that you call will get to me. Does that mean your phone is broken? No, your phone works.
Okay, makes sense.
Yeah, so your phone works, right? Your phone functions. If you call the one number, you get me. If you call the other number, you also get me. Your phone is functioning. It's fine. You see? Same thing here. After 1 month, there was 1.1, but that's the only amount of rainfall there was. After 2 months, there was 1.1, but that's the only amount. It can't be more than one amount of rainfall. So it's okay. It's a function. Other way around, obviously is not. If you pick, say, let's do a different example, 0.9. If you pick 0.9 inches of rainfall, does that give you just 1 month since January 1st? No, because that's 2. So going the other way around, R your input and T your output, that's not a function. Okay. So you have a few more on the web work. You have a few more practice like this, identifying the input, the output, and saying whether it's a function or not. Last chance for questions on this stuff. Okay. Let's go to page 88. I want you to work on number 4. A through E. Page 88, number 4. and I should say, the numeric answers are important, but what's more important is this question about representation. What do the symbols, what do the expressions mean? That's what we're going to focus on. Yeah, I'm just estimating from the graph, right? Yeah. Okay, so let's regroup. I think you got a chance to think about it. So with a graph, so with functions, we have lots of ways of representing functions. Why? Because it's not just about a method to solve problems. A function is about a process. Okay, so we saw, like last time, we saw the machine version. Like, so a function is like a machine. Here we're seeing it as a graph, right? So here we're showing a function as a graph. And when you graph a function, the input quantity goes on the horizontal axis, and then the output quantity on the vertical axis. Okay, so our input, this first question, input is the number of days since January 1st. Output is the weight in pounds. So let's just ask a question. Is it a function? If you have a certain number of days, is there only one weight that John could be after a certain number of days after January 1st? Can't be more than one weight, right? That makes sense. It's a function. Every time you pick a number of days, you get one weight that he was on that day, okay? So f of 60, I saw that as about 179. But the key is, can you interpret, if it was just said f of 60, what does it mean? So Austin, you're up. What is f of 60?
60 days after January 1st.
Okay, that's all true, but what exactly is f of 60 in all that you said? What is the f of 60?
60 days after January.
So that's 60 days. That's saying 60 days after January 1st. Is that what that's saying? Con. It's his weight. F of 60 is the output. That whole notation, that whole thing that I put a box around, is the output quantity, okay? It's the weight at 60 days, okay? And that's the same as 179. Okay, what about this? So I pulled off that for f of x equals 160. X is 15. What do you think? Morgan. What do you mean there's more than one?
Well, there's more than one, at more than one day in number of days, he's 160.
Okay, right, exactly. So that's the first one. But later down the road, right, what were the other? What did you estimate the other days to be? 120
Yeah.
and
And 175.
175. So I have more than one value of number of days that give me 160 pounds that he weighed. So is it a function or not?
I mean, one output gives you 3 inputs with that bit.
Yeah, it's a function.
Yeah, I would.
Patrick.
It is a function because I put 15 because it's one value.
Right.
It's like 20 is one value.
Yep. It's okay to have the same output more than once. What the problem is if you were to enter 15 and get 2 different weights, which we know is impossible. But since 15 days corresponds to one particular weight, always, we're good. 120 always corresponds to one particular weight. So this is perfect. It's still a function. It's still a function. Okay, let's go skip down to this one. So I calculated f of 200. All right, estimated from the graph, f of 200 was 185, f of 160 was 155, and I made this calculation 30. I got this number 30, and that 30 is that expression right there. What does it mean, that expression? Jonathan?
Change.
Okay, give me a change. Okay, be more specific. Change of what?
Change between days and
So is it a change in weight or is it a change in number of days? Change in weight. And which change in weight is it? Buddha.
Since changing the weight between too many days after January 1st and 160 days.
Okay, but that's 2 different weights. You just said 2 different weights. So
Yes, the change.
change from when to when?
It's 200 days after January 1st and 160 days after.
So she's saying it's the change from 200 to 160. Alex, what do you think?
It's like gaining weight of 30 pounds from day 160 to day 200.
Okay, so you said a gain. How do you know it's a gain?
Because it's a positive.
Positive number means the positive change. This is greater than 0. So it's an increase. So it's a gain of weight or an increase of weight of 30 from when to when?
From day 160 to day 200.
Yeah, so this is the starting day, right? This is the starting day, and this is the final day. Remember, to get the change in a quantity, you take, this would be the final weight minus the initial weight. So if we're going to say from one day to another, we're going to say from 160 to 200. Okay, so if it's a change in weight, how can I represent that with symbols? How do I represent a change? Yeah, Justin.
F of 200 minus F of 160 over 200 minus 160.
No, that's okay. So that's a rate of change. I'm just asking, how can I represent this change? What symbols can I use to represent this change? Nadine.
Use delta and say W is the weight of pounds with delta W.
Good. Delta W. And would that be delta Y or delta X?
Delta Y.
Or delta Y, right? So in the graph, it would be delta Y. And what is the corresponding delta X in this case? 40, right? From 160 to 200. So really what's happening here behind the scenes in this expression is we have a change in weight of 40 from 160 to 200. And then this calculates what? The did I say weight? Sorry. Change in number of days of 40. And then this calculates over that number of days from 160 to 200 days after January 1st. That calculates the change in weight. And like he said, it went up 30. It was an increase of 30. Okay, so, but why all that? So isn't f of 200 minus 160, or f of 200 minus f of 160, isn't that just f of 40? Can I just do it that way? Why not? So tell me why not, Anna. What, yes, so it's about what is f of 40. So what does f of 40 mean? Walter, what does f of 40 mean? The days. F of 40 is the number of days. Yeah, Adi.
It's the weight, it's the output for the weight after 40 days.
Right, this is a weight, right? This is the output of the function. F of 40 is an output of the function, so it's the weight 40 days after January 1st. And how much, estimate that? 178, 180, something like that? Okay, so we got that to be 178. And what did we get the change in weight to be? Earlier. Nowhere close, right? Because they mean two totally different things. F of 40 means the weight 40 days after January 1st. It's the output. This means the change in weight starting at day 160 and ending at day 200. And that's a change of weight of 30. Okay? But so this is a very common mistake. Students think that, oh, if I just plug in the change in the input, it'll give me the change in the output. Well, clearly that's not the case. You see that? You've got to find the initial output and the final output and subtract to get the change in the output. Okay. You bet.
For B, I put 180 and I still not.
It's just estimate from the graph. It's not, so this is much more about what these things, what these expressions mean. Yeah, so 180 is a perfectly good estimate. All right, so I'm going to flip back a page and do number 2. Up through D, up through question D. So back to right here. So just do A through D.
Get rid of the population, just look at it. Yeah. Yeah, H of A. Yeah. So this is just kind of like gives you the function notation. Actually, it's population after 8 years after 9 plus 3 years. So you,
after
Oh,
so you're gonna have like the H of K, which is your population.
H of 6 plus K.
the population of black
H of 6. Well, K years ago.
Yeah, you can put yes. You get that's 6 years now.
H of 6.
It would be H of 6 plus 7. I put H of 6.
Okay, let's see how you did. So part A, using function notation, represent the population of Blacksburg K years after 1990. Brooke, what'd you think? H of K, what do you think?
Yes.
That's the population K years after 1990. That's it, H of K. H of K. All right, how about the meaning of H of K plus 3? The meaning of H of K plus 3. Jacob, what do you think?
That means 3 years after the change in K from 1990. So that would be the population
That's the
in Blacksburg. 3 years after the amount of time after 1990 that K represents.
okay. So what you arrived there? Yeah. Okay. So is it a population or a number of years? This thing.
It's a population.
Population. Which population is it? Population of Blacksburg, right? But that's changing, right? So how in what year?
After K years plus 3 years.
Could you say K years after 1993?
Okay, we're getting there. Yeah. So K plus. How about K plus 3 years after 1990? All right, Nina's got a different way. Tell us, Nina.
Population of Blackberry K years after 1993.
What about, is it the population of Blacksburg K years after 1993? Does that work?
Yeah, that
No. Well,
I mean,
yeah. Actually, it does.
So think about K plus 3. So if this plus 3 would be 1993, and then adding K more would be K years later after 1993, right? So what she said was right. It's also, you can also say it's the population of Blacksburg K years after 1993. That works. It's good. All right, next one. How would you use function notation to represent a population that's 765 more than the population in 96? Christian.
H of 6 plus 760.
He wants, and where's the 765? Inside or outside the parentheses? This is what he's offered. What do you think? Agree with that? What would it mean if the 765 was inside the parentheses?
765 years.
Yeah, actually 771, right? If we put it inside, now we're talking about the population 771 years later. Totally different than this, right? Completely different. But this is what they asked for. Okay, how about this one? This change from M years, change in population from M years to M plus 7 years after 1990. Tim.
I got H of M plus 7 minus H of M.
What do we think? How do you do? Right, because this would be the final population, and this would be the initial population. To get the change, you subtract. Okay, there's a different way to explain this. Is there a different way of explaining this? There's actually, these weren't chosen randomly, M and M plus 7. There's kind of an intention, or there's some, it was kind of chosen deliberately.
Is it H of 7?
So is it H of 7, first of all? Does it equal H of 7? What would H of 7 be?
7 years.
What about 7 years? H of 7 is
Population of 1993.
this is the population in 1997. Is that the same as this change in population? No. No way. Okay. So no, that's not right. But if we look at a graph here, what is our input quantity is which? Is it number of years or population? So our number of years, here's on the axis. And so what is our starting number of years? So here's t equals 0, 1990. In this change of population, at what time do we start? M. And when do we finish? So what can you say about that starting and ending time, or that interval of time? If we start at M, and then M years after 1990, and we end at M plus 7 years after 1990, what could you say about that interval of time?
7 years.
Is it 7 years? 7 years. How can we show that symbolically? What does that 7 years, how can we show that 7 years symbolically?
Horizontal line.
Yep, Justin?
I was going to say delta x is equal to 7 minus 0.
Delta x is equal to 7. Just 7 years. So seeing it this way, seeing that that this comes from a change of 7 years, gives us a different way to explain that change in population. How could we? You want to give it a shot, Alex? So it's the change in population.
You repeat the question.
Yeah, so rather than saying it's the change in population starting M years and ending M plus 7 years after 1990, we can think of it more in the context of, oh, this is a change of 7 years. This is a change of 7 years, so how could we explain it a different way? Or what that represents? Anybody? Oh, Aaron.
It's a change of 7 years in a period of 9 years.
Is this a change of 7 years? What is this? Not a change of 7 years. Change in population. Okay, you're getting there. You're getting there. It's a change of population over how long? Period of 7 years, beginning M years after 1990. You see that? So that's a different way to look at it. It's a change in population over a 7-year period, beginning M years after 1990. So it's kind of like, since M can vary, it's kind of like saying we're looking at any change of population over any 7 years. You see that? It's a change of population over any 7 years. The beginning year being M, years after 1990. Okay, so if we have that, if the average rate of change, I know I didn't tell you this, so if the average rate of change is the change in H over the change in X, and we have our change in H is H of M plus 7 over H of M, how would we get the average rate of change? What would we divide by? 7 years. That would give us the average rate of change of population for the 7-year period beginning M years after 1990. And that's our average rate of change. And that's like we talked about average speed, remember? We talked about average speed. So that's something like average speed, but now it's not distance in time, it's population in time. Okay, questions on these? Okay, so we've seen, again, we're seeing all these different ways to represent functions. Here's still another. Tables. Where's my table? Okay, so this is not in your book, so this is my own original, or it used to be in the book. So you've got two functions here. Function f has an input of average length of workers' shifts, or shift length, okay? Shift length in number of hours. The output of that function then is the number of expected industrial accidents per year. So we're at some plant, or some manufacturing plant, okay? Function g takes the input of the number of workers employed each day. For various numbers of workers employed, it outputs the average shift length in number of hours. Okay? So based on these two functions, f and g, I want you to work through, you can talk amongst yourselves, work together on these questions over here to the right. Okay? make sure you understand the situation, and then work on these. Again, expressing with function notation. That's what we're working on. Expressing these values using function notation. Does that help a little bit? A little bigger?
So I guess you could say that. We have to use that. It would just be And the answer is talking about input or output. Output is something. Right. So I just really wasn't if you did f of 7, what would it be? What would the 7 be? 7 would be the average length of work per shift, since this is 7 accidents. The output of this. Yeah, you got it. Good. Okay, let's see how you did. So, Jared Smith, how many accidents would be expected when the shift averaged 11 hours?
I use A for the average. A equals
F of 11. Is that what you're saying? To represent it?
Yeah.
He wants F of 11 that would represent the number of accidents expected for 11-hour shifts. Is that right?
Yeah.
And what can we know what that value is?
Help from Walter. Okay, so F of 11 is the number of expected accidents if the shift length is 11 hours. Okay, average length of the shift when 70 people are employed. Christina, right? Yeah, Christina. So how would we express the average length of the shift when 70 people are employed? G of 70? How'd she do? G of 70, that's it. That's the output of G when the input is 70. And what is it? 7.5. Okay. Omar.
Yep.
Average length of the shift in a year with 7 accidents. How would you express that with function notation?
We have 9
F of 9.
equals this.
And this was to be F of 7?
No,
Why not?
because if it's f of 7, it would equal 5 accidents per year.
Okay.
And they wanted 7 accidents per year, which is 9.
They wanted 7 accidents per year, which is the input or output?
That would be the input would be 9, but the output is 7.
Right. So here they're giving the output, right? They're giving the output of 7 accidents. And so the corresponding input, which will be here, F of 9 is 7. Questions on 1 through 3? Does it make sense? It's not F of 7. You see why it's not F of 7? If it were F of 7, it'd be talking about this. An average length of 7 resulting in an output of 5 accidents per year. But here's what they're pointing at. They're saying, represent this with function notation. Well, that's F of 9. It's F of 9. Okay, so how many accidents would be expected in the year 65 workers are employed daily? Fuda.
15 accidents.
And tell me your process there. What'd you do?
I went to 65 workers.
Here?
Yeah. And I saw the output, which was 12.
Output is 12.
And then take that to the input of function f.
Okay. She said you take that to the input of function f.
It says 12. And that gives you an output of 13.
And tell me, why can you take the output of G and make it the input of f? Why can you do that? Same. The quantity, right? So its average length of a worker shift is 12, and that's exactly what the input into f is, the average length of a worker shift. So that's a fair move to take the output of G and put it as the input of f. And so you said that for 65 workers is 13 accidents expected. So let's go right down here to B. How can we represent that process with function notation? So what's first, Patrick?
You would say the f of,
But what's first? Let's do it the other way. What's first?
first thing is the second output, basically.
So-
The output of G.
Okay, and how do we express the output of G?
G of 65.
G of 65. So this is what we did first, right? And then?
And you say the f of G of 65.
Why?
Because the output of G is going to be our input for our function f.
You hear what he said? Well said. The output of G of 65 is now going to be the input of f, and so that's exactly how we notate that, right? So inside the parentheses for f is the input, but that is also the output of G when its input is 65. Okay? So how about 100 workers? Let's see, who else? Jaden, want to do 100? Tell me. Yeah, tell me the process. We start with? Is what? 8? 8 is the input of f. Output of 6. And he wants f of G of 100 is 6. How about it? How'd he do? Yeah. Exactly right. Okay, so what about... So, and this is called... I wish I could bring that back. Can I bring it back? No. Gone. All right, so this is called composition of functions. Composition of functions is where you string two processes together. Here we're doing the process of G, and we take the output of G, and we make it the input of F, and we get the final output. So it's a two-step process. It's a two-step process. So what about, look at number 6. Just go right to number 6. Does g of f of 9 have a real-world meaning in this context? So what is f of 9? And how would you explain it? So how would you explain what f of 9 is? Aaron?
It's the expected number of accidents per year.
Okay.
For workers that work a 9-hour shift.
If the average length of shift is 9, it's an expected number of accidents 7. So f of 9 is 7. So this right here is 7. And so what about putting that 7 into g?
It wouldn't make any sense because there's no input of 7 on there.
See, yeah, exactly. G has a certain function. What does it do? Its function is to take what?
The
Number of workers and give average length of the shift. What are we trying to give it? Number of accidents. G says, I don't know anything about number of accidents. My function, my only function, is to take the number of workers employed each day and tell you what the average length of worker shift is. So when you try to give me an expected number of accidents, I say, no, can't do it, won't do it. That's not what I do. Okay? So it does not. Right? So, okay? No. G of f doesn't make sense. Does not exist, doesn't work. Okay? What has to be true in order for a composition to work, to have a valid meaning? What has to be true for a composition to have a valid meaning? Who can summarize it? Alex?
The output of the term that's inside their parentheses
Right.
has to be an input of the second function. I guess.
So if this was valid, say it in terms of P and Q. If this was valid,
Q of X, whatever that is, has to be an input of P of.
exactly, whatever the quantity Q of X is, gallons of paint, that also has to be the input quantity for P. If those aren't a match, then that process wouldn't make sense. Okay? So now, what I want you to do is, I want you to make a new function h. That is the one-step version of what did we do before? What was the first step in the previous process? F or G? What was first? G was first. And what was the input of G? Number of workers employed each day. And then after we did the two-step process, what was the final output? Number of industrial accidents per year. So could we streamline this into one function? Could we do it? So quick, do it. Just jot a couple down. So just start it. We don't have to get the whole thing, but just start it. See if you can create a streamlined one-step version of this. Perfect. Okay, so give me one. Muhammad, did you figure out one of these entries in this table that would be part of the one-step process? 60? 90? And what was the output for 90? 90 and 7. Yeah? Let's see. Who else? Todd, did you get another one? 65 and 6. There should be 13, yeah? Yep, should be 65 and 13. Morgan, did you get another one? 80 and 8. So we can make the whole table, all right? So we can make the whole table. And the point, so both of these represent this idea of what we call function composition. This is the two-step version where you put number of workers into G, get the average length of the shift, put the average length of the shift into F, get the number of accidents. That's the two-step version of composition. This is the one-step version. It eliminates the middleman, right? It eliminates the middleman. All you do, you have the number of workers, and you directly get the number of accidents. Both are considered composition of functions. Both are considered composition of functions, yeah.
So you rounded up the decimals?
Maybe. Did I round some numbers? Okay.
7 would be like 11.5.
Yeah, so I had to extrapolate, right? There wasn't an 11.5 in here, so I had to guess based on these numbers. So I just made a guess. Okay. Cool. All right, so let's look at how this works with function definition. So I want you to go to read the description on page 92. Read the description for number 2. Page 92. Read the description for number 2. And then once you understand the situation, go right to D. You go right to D on the next page. So here's a tip. Ask yourself, what's the input? What's the output? And then if you're going to write a function definition, you have to come up with a rule. And does the rule involve the input quantity? Is it in terms of the input quantity, or is the rule in terms of the output quantity? The rule for the function. Is it an expression of your input variable, or is it an expression with your output variable? Rule, the rule for the function. Oh, we're not sure. Okay, so how about our V equals, remember the volume of the box. So it was f of x. And what was it? 11 minus 2x, 8.5 minus 2x. So that's a function definition, okay? That was our function definition. What was the input? And x stood for what? Cut square, cut out side length. And the output was? Volume of the resulting box. So now I ask you again, the rule in a function definition Is it in terms of the input variable or is it in terms of the output variable? He wants input. Agree with that? Yep. Your rule is in terms of your input variable because you're going to put the input in and that rule is going to generate the output, right? That rule is going to generate the corresponding output. So for each of these, this will help to set up the definition. Ask what's the input of f, what's the output of f, and what's my rule? What formula on the input will give me the output? Same with G, okay? So take 1 or 2 minutes, see if you can get that. Show me. So you want to check with me? Show me. Show me what you got. In the past, the success has been over here. And so, it's not a composition. All we're doing is setting up a function definition, just like the box. With input, one output. Yes, sir.
Yeah, instead of putting an R here,
No, but it says, yes, you're right. That's where we're going. That's what you're kind of skipping ahead. But if you do the function of the radius R,
right.
you want to do R, yeah. And that was my
Yeah.
Okay, so for F, what's the input? T or R? Is the input T or R? They're all saying T. So I'm going to do F of what? T. And then my rule, so that's notation, right? The output. The rule is going to be, is it going to be in terms of T or R? T. The rule is in terms of the input, right? So now what do we need? We need the rule that given time gives us the radius. If you're not sure, here's a good way to help you. Make a table of values. At 0, what's the radius? At 1 second, what's the radius? Based on the information given. 2 seconds. So having some values, a table of values, will really help you to see what the rule is. What is the expression of T that gives R? What's the expression on T that will give you R? 0.7T. There's function f. That's the definition of function f. Okay? Input of G. Is it radius or area? Right, it's the area as a function of radius. Output as a function of input, right? So G of R. And so what is the rule? The rule is going to have A's in it or R's in it? It's going to be an expression of R's that gives us area, which is what? For a circle. What expression of R gives the area of a circle? If you remember from geometry, pi r squared. So the next question is, what makes sense? F of G of X or G of F of X? Talk about it. What makes sense? F of G of X or G of F of X? What makes sense? 2 more minutes. Talk about it. Talk it out. What's going to make sense? Both of them? Neither of them? Just one of them? What's going to make sense? F of G of X or G of F of X? Stay, learn some math. Okay, so what do we think? Yeah, Aaron.
G of f of x because f of x gives you the input of area and your radius.
So you're saying the output of f is what?
The radius.
He's saying the output of f is radius, and that's also the input of g. What do you think? That's it. This does not work because you're trying to put what? Area into f. F says no way. That's not my function. I don't deal with area. Okay? So I just really quick. Hold on 1 second. So watch. So we can take that f of x right here, 0.7t, and we can put it in there. So if this is f of x, we're going to put it into g. So we'll do g of 0.7t. And what does g say to do? It says take the input and square it and multiply by pi. So we're going to do that. We're going to take the input and square it and multiply by pi. And I can simplify that, and I get 0.49 pi t squared. What I just came up with was a new function called h of t. What's the input of that? Time. What's the output? See, we just found the one-step rule. There's the one-step rule that bypasses radius. Put in the time, it gives you the area. So that's the one-step version. Here's the two-step version. Okay, get started on your homework soon. Have a good weekend.